Molecules of compound. Molecules, as we know, are formed when atoms combine together or come together in definite proportion as per the law of constant proportion. The example that is given over here is sodium chloride, wherein one atom of sodium combines with one atom of chlorine. As you see in this case, the picture that is given, the one in gray is sodium and the one in green is chlorine. So one of each combines with each other to form sodium chloride. Okay. Similarly, you have water, which is H2O, and we know that the ratio of hydrogen to oxygen in this combination is 1 is to 8. So you see how this is formed. See in this case, okay, hydrogen molecules interacting with oxygen molecules, and you see over here these two white are hydrogen molecules and this one is oxygen atom, and this molecule is referred to as H2O, or what we commonly know it as water. Coming to ions, what are ions? Now metals and non-metals, okay, they form compounds. Now usually metals combine with non-metals or something else to form compounds. Okay. Now they possess a charged species. When we say charged species, meaning the atoms present within that molecule have got a charge. It can have a positive charge or negative charge. And these charged molecules or these charged atoms are referred to as ions. Okay. Now, if the atoms have got a positive charge, then we call it as cations. If it is a negative one, then we call it as anion. Okay. For example, that is given is sodium chloride. Now, in the sodium chloride, sodium has a positive charge and chlorine has a negative charge. Okay. You see this figure. This is an atom, and an atom, if it gives out electrons, okay, then loss of electrons is considered to be positive because electron has got a negative charge. So if it gains an electron, as in this case the arrow should have actually been here, reverse fashion, but it's trying to show you over here that when an electron is gained, then the ion has a negative charge. So remember, when an atom gains an electron, it gains a negative charge because electrons are negative. Losing a negatively charged atom leads to positive charge increase on the particular atom. Okay, and you look at this. This is of a schematic diagram of the sodium chloride you see over here, and if you notice over here, they have drawn the electron configuration, basically how the electrons are placed in different orbits, and we have learned this in the video which showed how electrons fill up various orbitals or shells. If you want the link to that particular video, it will be down in the description. Okay, and have a look at the combination of the two. Okay, one is sodium, the one in blue is sodium or purple. Sorry, the one in blue is sodium and the purple one is chlorine. Okay, and if you notice, chlorine has got 7 electrons in its outermost shell and needs 1 electron, okay, to complete its octet, which we call, or the complete stable configuration of 8 electrons in the outermost orbit. Whereas on the other hand, sodium has got 1 electron extra in the outermost orbit. So to gain stability, all it has to do is lose that additional electron. So when sodium loses the extra addition or shares that with chlorine, it gains a positive charge because it is losing that particular electron. Whereas chlorine, on the other hand, which needs 1 electron, accepts that from sodium and gains a negative charge. That is why sodium has got a positive charge and chlorine has got a negative charge because of the fact that it accepts. And because of the fact that sodium does not need 1 and chlorine needs 1, that is why what happens is they form a perfect pair, a perfect partnership between the two, where sodium does not need 1 and chlorine needs 1. Okay. Now sodium being positive, is referred to as cation because it releases one electron, and chlorine on the other hand is referred to as anion because it accepts one electron. Classification of ions. Now, ions are classified as monoatomic or polyatomic based on the number of atoms are there. So, ions possessing only one atom are referred to as monoatomic. For example, sodium, potassium, etc. Okay, and ions possessing more than one atom are referred to as polyatomic ions. What it means to say is, you see over here, in this case there is only sodium, there is only potassium. In this case there is carbon and there is oxygen. So there are atoms of carbon and atoms of oxygen. So such a molecule is referred, or such an ion, since there is a charged particle, CO3 is a charged particle having a -2 charge, and NO has a negative, actually I think it is NO3, which yeah, it's NO3, not a superscript. That means NO3, 3 should be down like CO3 with negative side on top, is also a charged particle. So polyatomic, these are known as polyatomic ions because of the presence of more than one atom. And here this is there are only one single atoms, hence they are monoatomic ions. See, we've learned about this in great detail in the videos that we went through. Again, the link to those two videos that will explain in great details how we get valency is present in the description below. Now, valency is known as the combining capacity of an atom in its outermost shell, not in its valency, combining capacity of an atom. And that actually refers to the number of atoms present in the outermost shell, which become the valence electrons. Okay, and the valency is decided based on whether the atom needs an electron or needs to lose electrons. Okay, now it is defined as the number of electrons that an atom may lose or gain during a chemical reaction, or the number of electrons shared, because in terms of ionic compounds that form atoms which form ions, they are referred when they get together, they form ionic compound. Then there are those which do not lose or gain but share their electrons. These are referred to as covalent compounds, and they form covalent bonds, and that is why it is mentioned over here, or the number of electrons that may be shared. Example of valence in water molecule, here you have H2O, where two atoms of hydrogen combine or meet up with one atom of oxygen. Here the valency of hydrogen is 1 as it combines with oxygen atom by one single bond. Have a look at this. A single bond tells you the valency of hydrogen and means its combining capacity basically. Valency of oxygen is 2 as it combines with two hydrogen atoms. So it is an ability to combine with two um, bonds with two other atoms, because the valency of oxygen is 2 minus, because it needs two electrons. So hydrogen has got one electron which it shares, it does not lose. Hydrogen atom does not lose its electron, it shares it. So in this case it is sharing it with oxygen atom, and there is only one hydrogen atom electron, sorry, there's only one electron in the hydrogen atom, and that it looks to share with the oxygen outermost, the electron in the outermost orbit of an oxygen. So it forms a good stable partnership, but oxygen needs two electrons, so it gets it from two hydrogen atoms, because each hydrogen atom has got only a single electron. Here are some common simple and mono and polyatomic ions that you see. Some names of ions that are given: sodium, potassium, silver, copper. These are all monoatomic. Okay, and magnesium, calcium, zinc, iron, copper, aluminium, iron. Then you have polyatomic ions, which are ammonium, NH4 plus. Then you have hydroxide, OH minus, and nitrate, which was supposed, this is what we were supposed to have, and not NO raised to 3 minus, but NO3 with a minus charge. Then you have hydrogen carbonate, HCCO3 with a negative charge, and carbonate CO3 with a negative 2 charge. Then you have sulfite with the SO3 having negative 2 charge, and sulfate with SO4 having a negative 2 charge. And then finally you have phosphate, PO4, having a negative 3 charge. So these charges actually tell you a story. The story is that how much electrons it needs, or how many electrons can it lose. For example, PO4 needs 3 electrons to gain stability, and someone like NH4 or NO3 needs just 1 electron, but NO3 needs 1 electron, and NH4 needs to give 1 electron or share 1 electron, which it usually does with something like chlorine or something which needs an electron. Okay, have a look. There are different. These are also showing you metallic and non-metallic. Metallic and non-metallic are hydrogen, hydride, chloride, bromide, iodide, oxides. Okay, these are metals. Sodium, potassium, silver, copper. These are metals. Okay, so some of the things which are there in your textbook, which you can refer to in terms of the number of ions, name of ions, and the symbol with respect to them. Writing a chemical formula. Writing a chemical formula should become easy if you know the valencies of those atoms of that particular element. And for that, once again, you need to refer to those two videos that have been done. Now, here we will only focus on the rules when it comes to combination, how they combine with each other. We follow certain rules, and we'll use those rules and the knowledge that we have about valencies to combine the atoms of two different elements and form compounds. Okay, so first rule says that we need to cross multiply the valencies of the atoms to form the formula of the respective compound. Okay, and now what is not shown out here is that the positive and negative charges, at least in the first case, it just says H combines with Cl, that is actually hydrogen combining with chlorine. Hydrogen has a valency of 1 and chlorine has a valency of 1, but the difference between the two are the charges. Hydrogen has a positive 1 charge and chlorine has a negative 1 charge. You will never find two um, you will never find compounds that are formed of the same charge. They have to be of the opposite charges. Okay, so you have, these are compounds we are talking about, not just molecules, just compounds that are formed over here. This compound, if you notice, hydrogen has a positive 1 charge and chlorine has a negative 1 charge, which is not shown over here, and that 1 gets cross multiplied. So one valency of 1 which is there of chlorine multiplies with hydrogen, and valency of hydrogen, which is also 1, multiplies with chlorine. When it is 1, we don't mention it in the final compound. We don't say H1Cl1 or 1H and 1Cl. We just write it as HCl, hydrogen chloride. That's how it is shown here below. Next, we come to H combining with S, which is sulfur. H is hydrogen, H is hydrogen, and S is sulfur. Okay. Now, if you notice over here, sulfur has a charge, that valency of 2, and hydrogen has a valency of 1. Remember, sulfur has a negative 2 charge and hydrogen has a positive. So once again, the positive is combining with negative. The negative, forget about the negative because that doesn't really come into picture when we get the compound. It is just for your knowledge that there is a negative charge combining with the positive charge. The opposite charges attract. So we have the valency 2 of sulfur, that is combining, that is multiplying with hydrogen, and one valency of hydrogen multiplying with sulfur, as a result of which what we get is two atoms of hydrogen and one atom of sulfur, as you see H2S. But note over here, it does not say 2H1S or just 2HS. It says H2S. Okay, it says H2S, shows you that they are actually combining in that fashion. So when you draw the structure of this particular compound, it will be that the sulfur molecule sulfur atom is in between, and there will be two arms of that sulfur atom, just like how we have arms of water molecule, where what oxygen atom is in the center and you have two arms of hydrogen coming out from the oxygen atom. Similarly, over here we will have a sulfur atom in between and two hydrogen atoms coming out from the sulfur atom, and they form H2S, which is hydrogen sulfide. Next, we have aluminium, which is Al, combining with oxygen. Now, aluminium, now here the charges are given. Aluminium has a positive 3 charge, whereas oxygen has a negative 2 charge. And 2 of oxygen multiplies with Al and 3 of aluminium multiplies with oxygen, as a result of which you get Al2O3. Once again, notice it does not say 2Al and 3O. It says Al2 or O3, which means this is how the structure, the writing of that formula is based on the structure, how it forms. So two atoms of aluminium actually go on to combine with oxygen. Over here we see magnesium chloride form MgCl2, wherein magnesium has a positive 2 charge and chlorine has a negative 1 charge, which goes and multiplies with magnesium here, and positive 2 goes and multiplies with chlorine, and we get MgCl2 out here. So this is the first row of the writing of the chemical formula. Next, you have the second rule. So it says if a compound consists of both metallic as well as non-metallic elements, then name a symbol of the metal is considered first. So we talk about magnesium chloride. Magnesium is a metal, whereas chlorine is a non-metal. So you see, metal always comes first, non-metal will come next. And the third rule, what does the third rule say? See the figure over here. So in the third rule it says, in case compounds are formed from polyatomic ions, okay, then the ion is enclosed in a bracket before writing the number to indicate the ratio. But in case the number of polyatomic ions is 1, then there is no need for a bracket. Have a look over here and see if there is another figure. Okay, yeah. So in case if the charge on the polyatomic ion is 1 and the metal that is combining with it is having a charge of also 1, then there's no need to write the charges. It just says NaNO3. Okay, but in this case down, calcium hydroxide that we see, that is formed with calcium Ca and hydroxide ion, which is OH, hydroxyl ion, which is OH. Calcium has a positive 2 charge and OH has a negative 1 charge. So this negative 1 goes and multiplies with calcium, and this 2 goes and multiplies with hydroxyl. But if you notice over here, we do, since this is a polyatomic ion, we put a bracket, okay, around OH, and we put the 2 down out there. So it becomes CaOH2. Okay. So here you go. So, this is how we write molecules when polyatomic ions are involved. And last, in this video, we'll just go through molecular mass and what is actually molecular mass. We've learned that atoms have got masses, right? So like when we spoke about hydrogen and oxygen, or carbon and oxygen, we said that hydrogen has molecular mass or atomic mass of 1, and then we have the oxygen, which has an atomic mass for each atom, it's 16 grams. So molecular mass of a substance is defined as the sum of the atomic masses of all the atoms present in a molecule. Like if you take CO2 or H2O, CO2's carbon atom has a atomic mass of 12 grams, and oxygen atom has a atomic mass of 16. But since it combines with two atoms of oxygen, that means 16 plus 16 becomes 32, and 32 combines with 12 of carbon to give you 44 grams. That 44 grams is actually the molecular mass. So when the sum of the atomic masses of all the atoms present within a compound, that makes up a molecular mass, and it is expressed as atomic mass units, or just AMU. And here in this example, we are given that of water, wherein two atoms of hydrogen, each atom of hydrogen has a one atomic mass, unit of one atomic unit, and that combines with 16 of oxygen. Okay, so that would be total of 18. The molecular mass would be, in this case, 18. So we say 2 into 1 plus 1 into 16. That gives us 18 atomic mass units. Okay, or just 18 units. So we see how we can, we know now how we can calculate molecular mass of any molecule. Okay, remember molecular mass is all molecule. That is why it says molecular mass. Okay, it's the total mass of all the atoms present in a molecule.